Hello, geometry students. In this lesson, we're going to talk about arc length. Now, don't get confused with arc measure. We did that earlier when we talked about the degree measure of an arc. If you look at this arc, it looks like this is a 40-degree angle, making this a 40-degree arc. But that's not what we're looking for. We're actually talking about the distance around. We're going to take a tape measure and figure out. That will actually depend on the size of the circle. There are a couple of formulas. I think that this one is the most intuitive, but I'm probably going to focus on this one just because it's probably the easiest. And it will be the length of the arc is equal to the central angle, and then you've got actually the circumference divided by 360. So I start by refreshing your recollection on finding the circumference of a circle. Find the circumference of a circle with a radius of 11 feet. Well, circumference is 2r pi. That's the answer, 22 pi feet. Now, of course, if you want an actual distance, it's about 69.1 feet around that circle with a radius of 11 feet. Find the diameter of a with a circumference of 75 meters. This is a backwards problem. So circumference is equal to 2r pi. You'll notice there's actually a second formula that uses diameter. I can only remember one thing at a time. So 75 meters is the circumference. I'm going to find the radius. So the first thing I need to do is to divide by pi. Whoops. Actually, I have to do that. It gives me about 23.87. That's equal to 2r. Well, that's actually the answer. If you divide this by 2, you get the actual radius, which is 11.93. But then to get the diameter, you just multiply that back by 2. So that doesn't really make much sense. Back to 23.87. Just to show you what I meant by that was, I actually should use the second formula where this is your diameter. Radius of a circle or swimming pool, etc., etc. This is just circumference is 2r pi. I want to find the circumference. The radius is 2.3 meters. And there's the answer. 2 times 2.3 times pi. That's 14.5 meters. What that means is if this distance here is 2.3 meters, then the distance all the way around is 11 meters. Oh, excuse me, 14.5 meters. I was thinking about the last problem. So that's what circumference is. Arc length is part of the circumference. I'm looking for how far around is this. If this part is 5 meters, how far is this? If you want to actually think about it, you take this 5 meters, you could wrap it around. I've got 5 meters here, about 10 meters there. So I'm thinking this is going to be about 12. I'm just going to go straight to the formula. The formula needs theta, which is your central angle. It needs the radius, which is 5 meters. And then arc length is equal to theta times 2r times pi, all that over 360. Put that in your calculator and that will be your answer. And like I said, I think it should be in the neighborhood of 12-ish. But I don't know. It's actually giving me 25 pi over 6, which is okay. I actually like the exact answer. But if you want to know a decimal approximation, 13.09, which I was actually close to being right. So there it is, arc length. The measure of this arc is actually 150 degrees. But because the circle has a diameter, a radius of 5, That's what I'm looking for, is the length. How far around is it? So for example, if this distance here is 6, I want to know what is this distance here. And it looks like it's going to be maybe in the neighborhood of 6, probably a little bit less. I need the central angle, and I need the radius. It's equal to the central angle times 2r times pi, all of that over 360. The 360, of course, comes from the number of degrees. This is 4/3 pi. Which is 4.2 meters. I'm going to put the box around that. And again, it seems reasonable. I thought it was going to be less than 6. A circle is 34 inches in diameter, and I want to find the length of the arc that has a. So I'm going to do this as a backwards problem. Circumference is 2. Pardon me, I want to use the arc length formula. It's equal to theta times 2r times pi, all that over 360. I'm going to fill this in based on what I know. It has a diameter of 34 inches. Well, this is the diameter. So I'm just going to put 34 here. The 360 is part of it. Find the arc length. That's what I'm trying to find. If the central angle is 150, I didn't realize it was that basic. So theta, the central angle, is 150. The diameter, they told me, was 34, which means that the radius is 17. But you multiply that back and just plug it in. 150 times 34 gives me 85 over 6 pi, 44.5. You can sketch a picture to get the idea. I have a circle with a central angle that's 150 degrees, and the diameter is 34 inches, making this 17. So I guess that seems reasonable. 1, 2, 3. You get the idea. How about a backward problem? I want to find the circumference. This 81.64 refers only to that portion of it. This is not the circumference. So the arc length in this case, I'm going to do the formula, is equal to central angle, 2 times the radius, times pi, all over 360 degrees. Well, in this case, they're telling me the arc length, 81.64. The angle that goes along with it, it's actually one of these bent back angles, 260. Trying to find the circumference. Well, here's the thing about this. This is the circumference. So I'm going to leave that by itself. What I'm going to do, I'm going to start by multiplying both sides by 360. That gives me 29,000. $113.04. Now, do I need to go any further? It asked me for the circumference, so I could find the radius by dividing that by 2 and then dividing it by pi, and I would get the radius is equal to 17.9. It's actually, the radius is actually equal to 18. But to find the circumference, you would go 2 times the radius times pi. That gets you back to 113.04. So the key to this is recognizing that the formula for the circumference is actually contained in, that is the circumference. It's actually contained in the actual formula. So the circumference is right there.